Ignition.
Welcome back to the Cycle World podcast. I'm Mark Hoyer, editor-in-chief. I'm with Kevin Cameron, our technical editor. This week's topic is one near and dear to our hearts, the Yamaha RD350, RD400, probably the RZ350, and maybe it's barbell crank.
Yes.
And but really starting with the Yamaha two-stroke twin, which is the stuff of legend. RD350s, known as the giant killers. They were lightweight. They had chassis geometry not far off of the TZ350 race bikes. They formed the basis for TZ750s and etc. And they were easy to work on. They were lightweight, could be made to make a lot of power. I dug into the archives and found Yamaha racing tips, loose leaf binder, 3-ring, also Yamaha racing parts for you Spotifyers. I'm holding up beautiful yellow and black Bumblebee binders with, I don't know, two-stroke Bible stuff in there. And
special tools and how to use them.
So yeah, that's beautiful.
In this wonderful 1960s style.
Yeah. So Kevin's got obviously a lot of experience with all this stuff, and he has even more paperwork than I do.
What happened in the beginning was that everybody's got to do a twin eventually, because singles just, you make them bigger, you run into trouble. Yamaha had as an inspiration a German Adler twin, and they did not copy it. They didn't like the fact that it had only 4 speeds, so they had 5 speeds. They didn't like the method of attaching the 2 crankshafts together with a hearth coupling and a big draw bolt. So they went to a press-fitted inner pair of crankshaft flywheels. A lot of things were different on Yamaha's early twins, but the one that hit the market and really caught a lot of attention was the YDS2. And the YDS2 was built like the Adler on a vertically split crankcase, which meant if you imagine the crankshaft floating in midair with all its bearings and spacers, and the 2 cases are coming closer and closer with Yamaha special tools to draw them together, and I forgot to put the gasket sealer on, let's take it apart again. And eventually, those vertically split engines went as far as the TD2, which had 4 transfer ports, and it was really fast. In 1969, Yamaha decided to experiment with a horizontally split engine, and this was the R1 350 of 1969, and it was built like rational engines. You had the lower case, you set the crankshaft and all of its business in there.
Just a really easy to organize tray to put your parts in. It's really awesome.
Tray to put excellent. And then the gearbox shafts and the kickstart shaft. You put the top case on, or if you built it the other way. But once it was together, all you had to do was put on the clutch, the ignition, the outer covers, and you were done. Cylinders, you'll want those.
Yeah.
But those 3 years of 350 twins, mind you, all these engines are air-cooled, were a learning experience for Yamaha. And then in 71, I think, they produced the R5, which was an evolved 350 twin, and they had a bright idea. They said, we could build modular engines. They will all have the same 54 millimeter stroke. The 350 twin will have a 64 millimeter bore, and the 250 twin a 54 millimeter bore. And thus it was. And in fact, when TZ750 was built, 750A was built for the 1974 season. It had the 54 millimeter stroke and the 64 millimeter bore of the R5. Now, the R5 was a piston port engine, meaning that the rising and falling of the piston opened and closed a hole through the cylinder wall, the back of the cylinder. There was a carburetor there, so that when the piston rose, the pressure in the crankcase below dropped. And when it opened the port, there was a pop, a pulse of air went through the carburetor, picked up fuel into the crankcase. And then when the piston came down again, it compressed that mixture in the case until the piston uncovered transfer ports in the cylinder. The air in the crankcase came up through those transfer ducts to fill the cylinder.
Yeah, so we're talking, two strokes. Maybe most of you listeners, based on what we see in comments, probably have a pretty good idea about it. But pre-mixing oil and gas, a lot of these had the 350s, and you had oil injection. You poured your oil in a tank, and there was a little pump that was dripping oil in to lubricate all the bearings. But strictly speaking, you were pre-mixing a lot of times with two strokes to lubricate all the bearings in the engine. So that's going into the crankcase with that suction. And then a transfer port is a port that goes from the cases around the cylinder up to where the chamber is and gets shot in there so you can light it on fire. And
imagine a mug with two handles.
Yeah, and the handles are hollow.
Handles are the transfer ducts. Yeah.
But and the R5 was a five transfer, yes?
I can't summon that piece of information.
I believe it was a five transfer.
It would make sense that it would be, because it was the new era.
And then the 350 was 7, correct?
It was a tremendous piece of work, and a lot of people liked them. They were produced for 3 years. I think they made 25,000 of them or so, and then Yamaha was consulting with all these reed valve people. I think they had some conversation with the late Dale Herbranson. And they put reed intake, which is like a one-way valve based up like a saxophone reed backwards. So that made the engine easier to manage at lower RPM, where the exhaust pipe wasn't doing much pumping. And the thing about the RD350 was that, mind you, this is the early toward the mid-70s. English business practices had put a lot of nails in the coffin of British motorcycling, but motorcycles like the RD350 added a whole bunch more, because being lighter than what used to be the hottest of the hot and having pretty good horsepower. I think I see a claim for 39. I think these RDs would give a good challenge to a lot of British twins, and certainly to, when well ridden, to a big inch Sportster. So some people have called the RD350 the first sport bike. That's nonsense, because the Kawasaki Z1 was arriving at that time, but it was something that was a lot more affordable than those new monstrosities, and it brought high performance to a great many riders.
Easier to modify too. I mean, if you're starting with a big 4-cylinder, cylinder head porting and valves, and needless complication.
Yes. So what you did with an RD was, to get each head off, you undid 4 sleeve nuts, pull the head off the gasket, slide the cylinder up, and take the carburetors off first because they're in the way, and the exhaust pipes, and you've got the cylinders in your hand. And then you can raise the exhaust ports, you can widen them, you've got the cylinder heads.
Look at that.
And this circle here, that's the squish band.
Yeah, he's pointing to the squish band. So he's got an RD350 head. I'm assuming RD350, but it's the two pieces. The 350s had a cylinder head for each cylinder. The RD400 had a single piece, kind of more like shaped like a scoop. It was emission controlled, the 400, so it had an exhaust valve that made the head a little hotter. So they were trying to improve cooling and give it more surface area and all that. But this is a single cylinder head. He's showing the combustion chamber, which is round. You could chuck that up in a lathe, I bet. And
a lot of friendly machine shops had a mandrel with a 14 millimeter, 1.25 millimeter thread. You just put that mandrel in the lathe, spin this thing on there, and then you're ready to take 25 thousandths off of this gasket surface. And your compression up,
and then bang, you're getting a little more pop out of your...
Yeah, but that's how you know you're sincere. You've got to buy pistons in order to learn that business. That's the way it was.
Yep.
That's why the phrase fresh pistons. I imagine all these people looking like poor downtrodden seasonal workers moving slowly through the piston fields in the misty morning, getting fresh pistons.
Fresh pistons, plucking them from the trees.
Yes. But
well,
when the thing is that if you had a clue what you were doing and you had some basic tools, not a cam grinder, not you didn't have to be an industry. You could boost the performance of an RD350 or a 400 way up. Let's buy pipes. Let's put 34 millimeter carburetors on. A lot of people did. And I did it for them too.
Yeah.
But it was a transformation because from whatever the horsepower was, it went up about 25%, and you had something. And it was unfair. In racing, the guy that was finishing third would come to me and he'd say, "Can you help me out?" So I'd with the die grinder, and he'd phone me up and say, "Oh, it's great. I won the last race." And the other guys have to come and have theirs done. And in the end, the good rider wins. So all that was happening was that I was this parasitic creature sapping their funding.
No,
raise their performance level.
You're the bearded wizard in the shop, showing them the path to freedom.
Used to be the cellar dweller. Well, it was a lot of fun. And people spent many happy hours squatting or sitting cross-legged on the ground next to their bike on the stand, setting the ignition timing. And the way you did that was Yamaha special tool, dial gauge, adapter. This screws into the spark plug hole. Dial gauge goes in and is fixed with a set screw. On the dial gauge is a pointer. As the piston comes up, I've not put in the little probe here. As the piston comes up, you see the dial gauge swing around, stop, and then go back as the piston reaches top dead center and passes it. So if you want ignition at 2 millimeters before top center or 2.05, you back the piston down to where the pointer says that number, and you could be sure that you were doing it right. And it was nice to think of dinner at the same time. Put these bikes away. They're ready for tomorrow's morning practice. We're going to have a ball.
Well, I mean, the modification, you said, well, if you had an idea of what you were doing, you didn't even need to have an idea of what you were doing. You could wreck these things and rebuild them real easy. I mean, you could melt a piston, what you were saying.
Again, in under an hour.
Yeah. Four bolts, take off the head. 4 bolts per carburetor, take off the carburetors. If you had expansion chambers, usually there's a spigot bolted to the cylinder, and then it's just springs, and you undo the springs and slide your pipes out of the way, and you are in the engine. No cam chains, no flimsy little push rods to get flung out, no cam shafts, no cam grinders. You just did your thing, and in mere minutes you were inside. So they were really easy to work on. You could melt a piston, you could buy a piston. Gosh, they must have been nothing, or they would seem like nothing now.
Yeah.
But it is really nice. Couple rings. Not really too worried about oil control.
little hydrochloric acid on the cylinder wall to get the aluminum off. And you're going. In the early days, so many people went production racing with RDs. And some stiff-necked racing organizations insisted on stock foot pegs. And the original foot peg brackets came out from under the mufflers so that if you lean the motorcycle over like you were a racer, it would lift your tires up and you would slide off the racetrack. So people adopted an exaggerated Marc Marquez body to the inside style. We used to joke that RD riders, you could see the hiking straps hanging out of the back pockets, like were used on one design sailboats. And finally, the message got through and non-stock foot pegs were permitted. But
well, I heard stories of guys just bashing them with hammers, just putting different pipes on so that they would clear, and then bashing the foot pegs with hammers to just get.
Yeah,
they were stock. They were just,
or a body grinder with a coarse wheel. So they were highly active classes, stock class, modified class, of course, and that was what a lot of people did in club racing, RDs, in the days before the second generation of four-stroke sport bikes, or really before the sport bike, the smaller sport bike gelled in the form of the Honda Hurricane and the various Ninjas and Seicas. So it was a valuable vehicle for people who wanted to race something that was close to racing performance, and yet was really inexpensive to operate. And there's one of those rules of thumb for the amateur racer: don't race anything you can't afford to crash. And this is the hard thing for people who go to track days, because of course they want to look good. They've paid a lot of money for this beautiful motorcycle and they want to look good. But if they're not going fast, they don't look good. And if they crash, just look in the Ducati accessory catalog. It is so wonderful. Is there a reason to want to be rich? Yes, that catalog. All that gleaming carbon fiber stuff and the titanium parts and that's nothing to do with RDs. The thing about RDs is every person's race bike. And there were plenty of women riding them too. Maybe not plenty, but there were enough that it was no longer remarkable. So
stock RD350. Yeah, stock RD350 is a beautiful size, compact, human size, easy to handle. 344 pounds is what we weighed our test bike in 1973 with a half a tank of fuel, 344. Not bad.
No, that's not bad.
And the stock, the stock setup on those, stock pipes, stock carburetors, they're Mikuni 28 millimeters on the RD350 round slide. Yep. And they were pretty torquey. I mean, it was kind of a nice street bike. They made good power, pretty quick. I think our
slides like these.
Yeah, exactly like that. Standing quarter mile was 14:30 at 89.82. That's pretty darn quick.
Yeah.
400, the 79 RD400 wasn't much quicker than that, just barely. 14:18 at 91.37. So, good performing, but also you could completely change the power with pipes and porting, and you could go up in carburetor size, and away you went.
The way people used them had a lot to do with changes in the motorcycle, of course, over the 3 years. When they started out, the crank pins had holes through them. And, of course, the reason for a hole is you don't want to have to put any more counterweight than you have to on the crankshaft. But all these dark marks on here are the result of slippage.
Slipping in the press. So in the press joint.
In the press fit. And what some people, I remember this started to happen in a big way with the RD400 in modified racing form. A fellow called me up and he said, a weird thing is happening to my bike. He said, I always check the connecting rod side clearance after every weekend, which is, as we previously observed, easy to do. You just take a feeler gauge, put it down between the connecting rod and the crank cheek. And he said, my side clearance on the ignition side is increasing every weekend. And he said, what happens when it gets really big? And I said, you'll lose the main bearing on that side and your engine will seize. Yeah, I don't want that. So Yamaha's response was a solid crank pin, which increased the strength of the press fit.
Maybe we could talk about that just for a moment, because I think we're all so informed of looking at the insides of modern four strokes with plain bearings and split connecting rods, and you have fracture split rods that fit perfectly, and all of that nonsense. But this was a pressed together crankshaft, so you had a cheek with a shaft on it that was your ignition shaft or whatever, and then you put a bar in it, and you put your connecting rod, which was a complete circle with a bearing, and you slid that on the shaft, and then you set up your business in a big press, and you pulled your lever, hydraulic press, and then you started to jam that sucker together. And if you're smart, you have some jig type stuff to align up your crank wheels so that they're not so far out.
You don't want them to be.
Yeah, you don't want to be out of alignment, so you kind of get them lined up, and then you'd build up your stuff and you press it all together, and that was it. It was just pressed together. The XS 650s were like that as well, and all the race guys would weld them, so they didn't, I guess, fly apart. But
they hoped.
They hoped, yes. And so you would press that whole crank together, and then you'd have a rebuilt crankshaft with the new bearings and new connecting rods, and you slap your pistons on, and you drop that in your engine case, and away you went.
I was at a race in Thompson, Connecticut, and a guy I knew slightly at the time went by rolling his bike, which seemed to be pretty warm. I seized it, he said, but I have a crank. And 45 minutes later, he came by, engine running. He had changed the crankshaft.
Making popcorn.
So that's why they were so attractive, because there were a lot of people that knew their way around a simple engine, and they weren't afraid to just dive in there and do stuff. And so changing a crankshaft in 45 minutes was possible in those engines because they were simple. And you could, if you knew the dealer decently well, you could have a crankshaft sitting in your box for $100. Not bad.
Not bad at all.
1973. So that method of constructing a crankshaft is still in use today, but in only very limited use. I think Honda's 450 has a pressed together, the motocross engine has a pressed together crank, and the handbook that I remember looking at said that Conrad big end life was 10 hours. And that's about right. If you're going to insist, if you're going to push things to 10 or 11,000, the bearings are eventually going to just get real tired of that action, and you'll rattle to a stop, having pulled the clutch. And
right.
But there were a lot of people having a good time. They had a good idea of what they were doing, and it was a community. If you needed a piston, somebody 2 vans, 3 vans down on one side or the other had a piston. Oh, it's first oversized? Yeah, I've got that one too. So good fun in that time.
Well, years ago, I sent my RD350 engine to you in the mail, and flew out, and we rebuilt it in your shop. And it was cool because we found actual problems. This was an RD350 I bought off of eBay. First story, $1,000 bikes on a 1,000-mile ride. And the eBay listing was a big lie. We're salad dressing in the carburetors. My cam, my points cam had been sitting in one place with a wet felt for so long it was deeply pitted. So I had to get a new that's the cam that opens the points. It's on the end there, and it kicks your points open.
So far out from the bearing that it magnifies its error.
Yeah. And so I sent that out to you. And so we found real problems. It was a bike that had been ridden quite a bit, and it had pitting on the 6 gear teeth. It had been running sixth quite a bit. I had to order gears. I had to call a guy who had a gear set, and he sent them out to us while we were doing all of that. I think it was one of my most humorous failures to communicate between you and I was, I wanted to modify the bike. That's why I sent it to Kevin's shop and I flew out to work on it with him, is I wanted to modify my RD350 with Kevin Cameron's wizard-like porting so I could win the race. And as long as I was the rider to do it. And we talked about what to do, what to get. And I said, well, it's 28 millimeter carburetors. I'm going to get some flat slides, some Mikuni flat slides. I was thinking 30s, maybe 32s. And Kevin said to me, well, I guess if you want to put those wee little things on your engine, you can. And so when Kevin Cameron says put 34s on it, you get 34s. So I got 34s and came out, and I was just over on the other side of the shop cleaning the cases, and you had the cylinders. You had your little glasses on, and you had your porting tool, and you were over there with your octopus hanging from the shop ceiling or whatever, the rod, all the different cutters, and doing all of that. And you're talking about how you cut into the port, not into the cylinder, because if there's plating, you don't want to lift the plating. You want the cutter to lay the plating, keep the plating flat, etc. Lots of little tricks.
Cut towards the aluminum, yeah.
Yep. And so he's over there doing that, and I'm cleaning, chasing threads, and then he's just hogging away. And he finishes, and I say, well, Kevin, that's cool. How'd it go over there? Yeah, really good. We had some big action. We got out into space. I had to put a bolt in the transfer, he puts a bolt in, packs some, quick steel around it, epoxy, keeps cutting. We've patched the hole.
Yep.
And I said, yeah, so what's the power, because when I talked to Kevin, I said, I want a torque motor, I'm just going to ride this on the street. I want a pretty good torque. And he's like, oh, well, my motor's always made a little bit more torque than Irv's. And Irv aimed his ports, at each other, I think. And Kevin,
they were up.
Up. Okay. So they were up, and then Evan and then Kevin pointed his at each other.
A lot of flow on top. So the engines were really strong.
Yeah. And so,
but only Freddie could ride them.
Yeah. So I say in the beginning, before porting, yeah, I'm looking, torque. I want a torque motor. Kevin says, yes, I build a torquey motor. And so he finishes all of that. And I say, yeah, so what's the power going to be like, like 3 to 7? 6 to 9, and 5, what is it, 3? And I was thinking like, yeah, it's going to make power at 4,500 to 7,500 or something like that. And he says, he looks at me and says, 4, with a big question mark. 4? And he's like, no, 6 to 11, and you're going to have to get rid of the stock ignition because it'll slowly walk off the crank apart.
Yeah,
I was like, that was our failure to communicate. So I was getting a full race, whatever it was, TZ spec, full race, let's cut wood, power comes on, let's go. And that's what we got. So that's what we have.
Well, the thing is, the stock RD, peak power is at 7,500 and peak torque was at 7. So it wasn't what you'd call a broad torque engine, even in stock form. But the reeds helped, I guess, if you were having to obey the laws in an urban area. It made it into a docile scooter. But if you've got a good ignition and you have your carburation close, you can make it run. So it was it was an amusing thing though, because normally those RDs, people did rev them to 10, 5, 11, and the heavy stock ignition rotor slowed down the elephant ears flapping mode of the 2 flywheels on the ignition end of the crankshaft, so that the flywheel slowly slid off of the crank pin, like 4 thousandths, 6 thousandths per weekend. And the fix was easy. You put on a racing type ignition with a very light rotor, It raised the frequency beyond the firing frequency so that there was no longer, they weren't humming, they weren't on the same page of music, and no more walking off the crank pin. So, fun times. The stock engines for a long time came with connecting rods that did not have slots in them for fuel-air mixture, notably fuel, to be thrown directly onto the rollers. You could look through the slot and see the rollers. So for a time, there was a business of using a big abrasive disc to cut slots in the rods, but it was easier to just get the TZ rods in the first place because it was the same forging.
Oh,
really the same part.
You should have seen your face when I handed you the bearings that I had bought for my connecting rods.
Oh, did I make a face?
And you said, "Oh, how about we use these?" And he disappears into the back of the shop, walks around the 4360 radial aircraft engine, and comes back with TZ silver plated. So these are better. We'll use these.
We'll use these. Well, people did crazy things with 350s and 400s. I worked with a guy who he had his motor souped up. He had an aluminum swing arm. He had a TZ style gas tank. He had everything that he could spend money on. He spent it. I said, well, you could put TZ style foot valves in the bottom of your front fork diff. Oh yeah, I got to have those. On and on. Well, it was a sport for him, and he enjoyed every minute of it. He wasn't particularly fast rider. There was a day at Bridgehampton on Long Island when he had this modified monster, and he said, I think there's something wrong with my bike. I'm lapping around 2 minutes 10, 2 minutes 12. And I said, why don't we get Dave Roper to ride it? He loves to ride anything, and he'll give you an unvarnished opinion. Oh yeah, that's a good idea. So Roper goes out on the thing, and he comes humming past a couple of times. And third lap he comes in, and he's done a 203, I think. And Roper gets off, hands him the bike, and says, nice little bike. And the guy was crushed. So
yeah, wouldn't it be crushing? But
Dave,
these
social circumstances must be avoided.
He's a talented rider, still is.
The terrible thing about all of this is racing is a hard collision between human beings and the physical world, because if you're not fast, it'll show. And that's the great thing about racing, is that the people who are up front have learned how to do it. They learned. They aren't taking risks. They aren't daring speedmen. They learned how to do it. And that's the wonderful thing about the RDs and all of that low budget racing, is you're learning to manage life on two wheels. And it's the same as it is in Grand Prix racing. It's the same predicament. So you're in the zone if you're going well on your cranky old modified two-stroke, or indeed if you're on a CB350 Honda four-stroke, same era. They sold the daylights out of those things, so many. And of course, the vintage racers have bought up all the ones that still remain. Same thing with the RDs. It's just been there was a madness. Then there was 2008. Then there was COVID. And we don't know what's next.
So the 350 then turned into the 400. And that was just, they were dealing with the kind of nascent emissions business. They put a valve in the exhaust ports.
I don't remember that on the 400, but I sure do on LC.
Yeah, it was on the RD400. See, I had an RD. That was my first motorcycle. It was a 1979 RD400 Daytona Special.
I never saw that. Yeah.
My neighbor owned it, and it was 100% stock, had 9,000 miles on it, and I bought it from him and started riding it around. I did high side it. It was my first bike and my first high side, as many RDs were totaled. This one I bought, it was stock. I took it to some pipe guy up in Pomona to build chambers for it. His name was Tommy Crawford, a Grand Prix tuner who was doing a pipe business, retired from racing. I think he worked on Suzuki's quite a bit, TC exhaust, and built these beautiful chambers for it, repackable mufflers with a big circlip to take the packing out of the back. They sounded great, and man, did that thing, it was a good street pipe, ran strong, ran great, and then I crashed it and wadded it all up into bits. And that's when my parents said motorcycles were water under the bridge. And I say, haha.
Well, and where are you today?
Yeah. But it was great. It was, at the time when I bought the RD, that was the point of the story, is I went to pick it up from Tommy, and I was a kid, I was 16 years old, and he said, your wheels, your rear wheel was out of alignment. I'd never taken the rear wheel apart. I was still on these chintzy old worn out tires that the bike came with. And he's like, the wheel, it was a little crooked, so we straightened it out for you. And, you lined your wheel up. Did it feel like it was crabbing? I'm like, I don't know. I could barely ride the bike. So I had no idea that the wheel was out of alignment, but he did that. And then he said, and by the way, you have this exhaust valve, and it was wired open, and they just cut the threaded rod that was controlling the butterflies on it. They just cut it, wired it open, and that was that. And then I had my chambers. Ran great. It was really fun at that point. And then of course we had a lull in the United States until RZ350 8485. And that's when we got the liquid cooled 350, lots of power. It had catalytic converters, lots of heat.
Lots of heat.
Much heat, and
improved some of the fuel in the cylinders and the rest of it in the pipes.
Yeah, and making some real heat, but trying to keep the hydrocarbons under control.
Yep.
So we could have that glorious making of popcorn. But they improved the crank, and so the stroke went back down for the RZ350.
Well, the thing that was always a weakness with the modular engines that began in the early 70s was that there were 4 crankshaft flywheels, 2 crank pins. They were separate pieces like this, so there was a press fit on both ends. And the 2 inner flywheels went together by one of them having a solid shaft that fitted inside of a tube on the other. You press those things together, 7 tons, and they would break the smaller shaft. So they made a bigger shaft and a bigger tube for the racing bikes, the TZs, and then they had a modified bearing to accommodate the larger tube, and that stopped that breaking. But that meant that there was one flywheel that had 2 holes in it. They had one for the shaft going through the center and one for the crank pin, and they were as close together as the holes in a figure 8. Now, you'd expect it to break between there, but it didn't. It broke in all sorts of other ways, as if that was forbidden. The cracks would come and wander through the thing, and the most wonderful result was that somebody's flywheel would come in half, would open up at, say, 10,000 RPM, like a pair of steel brake shoes, and wipe out the crankcases so badly. So on TZ750, where the crankcases were $1,000, we learned to shot peen the areas where the cracks might form and to inspect by means of magnetic particles, look for cracks in all those crankshaft parts. So that's what happened as life progressed. We kept getting more power from the engines. The same old parts were running out of breath. So when they did the RZ, they made the 2 inner flywheels and the shaft connecting them into one piece. So that meant, and then they made the outer flywheels and the crank pins in one piece. So now there are only two press fits, and there's no flywheel with two holes in it. And that made the crankshaft a lot more resistant to failure at prolonged high RPM. Unfortunately, of course, 84, that was when the two-stroke thing was it really ended. No more street two-strokes. And there could have been a future for the two-stroke engine if they'd had all of that tricky direct cylinder injection.
Well, if
So
only the Bimota Vedue would have worked out, the 500 twin two-stroke. Boy, that had some problems. But we thought Bimota was bringing us a return to the glory days, but its injection system didn't work.
It didn't work. Just plain didn't work.
Just didn't run.
But of course, making motorcycles is a business, and there might be honor in carrying on with the two-stroke idea no matter what the cost, but businesses can't operate that way. So everyone looked at the options and they said, let the car industry do all the research for four-stroke emissions control, and we'll buy it over the counter and apply it to our four-stroke future. And the two-stroke thing just ceased to exist. All over with, except that crazy folk like ourselves harbor illicit parts and even whole motorcycles. Of course, it's legal to ride them because they're grandfathered in. But generally speaking, the difference between a two-stroke and a four-stroke burns roughly a half a pound of fuel to make 1 horsepower for 1 hour. And the two-stroke, nicely tuned one, more like 0.65 pounds. So an extra 30% of fuel is passing through the two-stroke and out into the open air where the EPA can detect it. And that had no future.
Yeah, you said after porting the cylinder on mine, you said, well, you'll find that at low RPM, you'll get pretty terrible fuel mileage because it's just all getting chucked out the pipe. You're not getting any energy from it. It's just basically migrating through your crankcases and out the pipes, and away you went.
Well, and that's why the later two-stroke twins had the eyelids in the exhaust, because if you were building an engine to operate at 4,000 RPM, it would have quite low exhaust ports. And if you wanted to operate at, say, from 9 to 12, you would have taller exhaust ports. And so the eyelid is simply there to open the exhaust at the point that is appropriate to the RPM the engine is making at that moment. And it was too little too late. It was a lovely device. There were other resonators were added to the exhaust, all sorts of things, water injection. But two-strokes were over with, because it would be another 10 years really before direct injection showed that it could have been done. But by that time, four-strokes were in production everywhere. People love them. And that's how it is to this day.
Yep. What's the practical RPM limit on a two-stroke like an RD?
Well, the RPM limit is quite low compared with four-strokes, because the process of passing the fuel-air mixture from one volume to another doesn't lend itself to 20,000 RPM operation. So when the 125cc cylinder was the module of Grand Prix racing for many years. So the 125 class had one cylinder, the 250 class had two, and the 500 class had four. And I think Honda got their 500 to run between 9 something and nearly 13,000 RPM. And I think the Yamahas ran a little short of that. But the thing was, a two-stroke fires twice as often as a four-stroke. And toward the end of their development, two-strokes were able to fill the cylinder at least as well as a fully developed racing four-stroke, which meant that a 125 single at the end of the two-stroke era was making over 55 horsepower. And the 250s, in 1994, Honda set as a goal, okay, fellas, this year our 250s are going to hit 100 horsepower. And the 500s, it was a tricky thing because with the power that they were making in the 90s, it went from like 160 horsepower to 190, even though the fuel was being de-leaded, which meant the compression ratio had to come down. 500s were tricky to ride because they had enough power to break the tire loose a lot easier than a 250 and especially a 125, so the power was softer. When the sidecar guys began to use Yamaha four-cylinder 500s, they wanted 250 cylinders because they made more power than 500 cylinders. They were just a little more radical. But then there was a company, a couple of outfits built 500s toward the end of the two-stroke era that made a lot more power than the factory, the Japanese factory 500s, but they were not rideable. They could go down the straightaway at a tremendous rate of speed, but they just stayed in the corners. And what the Japanese had done supremely well was to control the power valve or other exhaust device electronically so that they could say, oh, well, we use this program for this racetrack and we use this profile for this other racetrack. And there was the whole business with Big Bang. There were all these things happening. And it was a fast-moving time. But in the end, 500 two-stroke lap times stagnated because they couldn't feed power from zero. A four-stroke, you can start to turn the throttle in the middle of a corner if the thing is docile enough, and it will feed from zero so that you can accelerate as the motorcycle makes more traction available as it rises from full lean to upright. So you're adding power during that time. Four-stroke allowed you to do that very smoothly. The two-stroke, despite all these civilizing measures that were applied to it, remained hard to get off the bottom, so that you had Mick Doohan riding in that, it was once called a defensive style, with his inside shoulder turned forward, his body offset to the inside of the corner, and lifting the motorcycle up so that he could withstand the hit when the engine 8-stroked, 4-stroked, and then 2-stroked, and away you go. And he became good enough at that he won 5 straight 500 championships. And the reason that I've digressed here is that there was always a close relationship between what was going on the racetrack and what was happening in production two-strokes, including motocross. Lots of motocrossers were built with power band broadening ideas built into them, so that it was a kind of unity. It seemed like two-stroke was another country. And if you were in for an RD500 or RD350, you were in a group in which you could find Mick Doohan, and you were dealing with many of the same problems that he encountered trying to go fast on the 500. So it was when two strokes first arrived, there was that year when Yamaha 350 twins finished second and third in the Daytona 200. And at that time, the AMA had been contemplating a 350 maximum displacement because, as race sanctioning bodies always do, they were pulling their whiskers and saying, oh, it's too fast, too dangerous. Oh, think of the liability. And those two 350s in second and third, oh, forget that idea. We're going with 750. And that's what they did. So two strokes were always there poking and pinching and offering a low cost, violent solution. And
Yeah.
I enjoyed the daylights out of it. It was a good
Yeah.
time to have a die grinder and a gas welder. Or if you lived in California, of course, every garage had a TIG welder in it.
Well, I cracked up because you said something about, the power coming on a, TZ 750, or maybe it was the RD, but after it was ported, and you said, well, once you, whatever you said, once you got to 9,000, time to cut wood.
Yeah.
It was just wait, and away it goes. It's a thing of beauty. If you want to just rattle down the road, short shifting and so forth, your XS 650 is a great way to roll, right? Like tip, 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 as you say, you can pick up from zero nice and smoothly, and you can short shift, and you can kind of pitter patter down the road. But two strokes aren't as amenable to that. They can be made to run like that, but as soon as you put a little sizzle into them, away you go. That bottom end, forget about it.
Yes, it's like the Saturn V rocket. There's no part throttle when you take off. There is part throttle once they get up to a certain altitude. They had to throttle back. They called it max Q, which is the greatest resistance from the atmosphere. But like Saturn V, a two-stroke required a full commitment from the passengers because it was an unmanageable application of fire in a closely confined space. And it acquired all of this complexity, the complexity having to do with how the streams enter the cylinder, how they loop up to the cylinder head and down to the exhaust port just as the piston is about to close the exhaust. All of that took a tremendous amount of thought and repetitive testing. And it did its job, and it was over with, and now it's just history. It has no application, but the two-stroke principle lives on in the gigantic engines that power world trade, because every one of those container ships has something like a 100,000 horsepower two-stroke diesel, 2 stories high, driving a 30-foot propeller directly. The engines, the power band, 80 RPM. 80. So, and the reason that it's in that job is that it packs the density of power that allows the ship to carry the maximum amount of cargo. It's business. And of course, when two strokes became bad business, they were no business at all. That's where we are today. I mean, there are still people playing with the principle, and there have been a few low production direct injection or transfer port injected engines, and you have to admire their persistence. But the problem is that a small industry cannot as easily afford the pioneering, the endless testing that is required to meet EPA. And when it proves not to be easy, it doesn't happen.
Well, 302 strokes, transfer port injected or no, are still the greatest off-road bikes. All the torque, all the lightness, the power you want, when you want it.
True.
Great immediate response. They're still doing those. KTM and company are still making the 302 strokes, and they're magnificent.
Yeah.
I wanted to talk, so when I was there years ago, and we were out in the shop, and I said, well, It was time for dinner. We were going in, and there was a porcelain lined pot with some stew in it or something. And I said, well, let's talk about, transfer, the theory of transfer ports and how all that works. And he said, oh God, we'll be up all night. And I said, yeah, maybe that's a lot to tackle. However, how did you figure it out? Were you looking at the combustion, the piston crown? Did the piston crown tell you things?
There's a bunch of evidence that you can gather, and the piston crown is one of them. Ideally, you would want the piston crown to be the usual sort of soft light gray and with hardly a mark. But if you're a bit rich, there will be deposits on the piston crown that show where fuel has partially carbonized in contact with the hot aluminum. And so you can get an idea if things are going in the direction that the port appears to be pointed. But one of the basic problems with these engines is that, and it is a problem with the RD, is that they're 180-degree crankshafts. So you would think vertical shaking force is self-canceling. That would only be true if the two pistons were somehow moving this way, as they do in a BMW, boxer motion, but they're offset. And because they're offset, the crankshaft rocks from side to side. And in all of Yamaha's early parallel twins, this broke the frame sooner or later. So what they did was they knew that this rocking motion was going to break things. So they pushed the cylinders as close together as the transfer ports would allow. And the result was transfer ports that did not resemble the two cup handles on a mug, but which resembled an elevator that goes up to the floor and the door opens and you go out at right angles to the elevator shaft. And air does not like to go around a sharp right angle like that. And it won't do it. In an air conditioner ducts, they put little guide vanes in the middle of the duct to sort of help things out. But if you feel around in there with an impact probe connected to a sensitive gauge, you can map the outflow from the transfer ports by setting the cylinder down on a blower box, blowing air through the transfers, and you map it out, and you find out only the upper 2/3, or maybe even as little as 1/2 of the transfer windows are flowing anything, because the air going around such a sharp corner goes out to the outside, and it does not follow the much sharper corner on the inside. Same as the 4-stroke short side problem. How are you going to make the air turn down the near side of the valve? So what Yamaha eventually did was, you have a parallel twin like this. They made a 90-degree V-twin like this, which allowed the cylinders to be spaced a little bit closer, but most of all, it made room for those cup handle transfer ducts. Nice, graceful ones. And Jan Thiel, who did so much for European two-strokes in the day, he and his friends built from zero a 50cc racer that won the world championship. So those fellows learned a good deal. And Jan Thiel said, my engines really started to make some power once we got those gracefully curved transfer ports. And that was a real problem on all of those parallel twins where the cylinders were crowded together so that the transfer ducts had very little room. Suzuki helped that problem a little bit with their two transfer, like their 750 so-called Water Buffalo. They rotated the cylinders, this is looking down on them from above, so that the transfer ports were next to one another rather than being crammed together.
Sure.
And that's the engine that Gary Nixon, of which Gary Nixon once said, "That'd be a pretty good little engine. It wasn't damn hard to ride." It had, with due respect to Gordon Jennings, who said, smooth, broad power bands come from exhaust pipes with gentle tapers. Well, those 750 Suzukis had gentle tapers, but they had a violent power band that was like on and off. And that's why Gary said that, if it weren't so damn hard to ride.
Mm.
And so those V-twins were a step forward in 250s, but they didn't arrive until it was time for the two-stroke to exit stage left. So there are a few of them, the productionized ones around. Good luck finding pistons. But it was fun while it lasted.
It was. Still is a little bit for a
And
few
of
of
course,
us.
we have to remember that two-strokes began to appear to annoy people. In 1970, Ginger Malloy was second in the World Championship on a Kawasaki H1R, a triple, production racer that he had bought for $1,500. And there was Agostini on high. And
Count Augusta cannot be happy about this.
yeah. And there was old, good old Ginger, tricky, crafty old guy, wonderful character. And
Arturo Monti, who are these pirates?
Yes. So, but it kept coming. It kept coming. And Suzuki won the 50cc championship. That was the first two-stroke win of a world championship. Then the 125, then the 250. And by 1975, every class, including sidecar, was won by a two-stroke. And that's why the English and the Australian four-stroke folk referred to that as the forgotten era, because they wish they could forget it. And in 1975, things were just starting. Two-stroke 500s were making 90 horsepower, 100 horsepower, and it just took off from there. And the reason the four-strokes didn't have a chance was that it probably cost between 10 and 100 times more to get 5 extra horsepower by four-stroke than by two-stroke. Because with the two-stroke, you just had the people in the dyno room working, and periodically they'd phone, "Hey, boss, we got something. We got something." And Honda liked to make out that, well, we have this powerful computer which answers all our questions. But in fact, the way the two-stroke horsepower was developed is there were two drunk fellows in the basement of, I don't know whether it was HRC, it might have been too early for that, but they worked in the basement of the big research area, and they had a system of exhaust pipe cones that could quickly be snapped together to make different shapes that would give them some idea within minutes. And they're in there with die grinders. They're doing exactly what the RD350 guys were doing. They were finding their way, cut and try. It was wonderful. And it was wonderful to hear that that's how it came about. And what would happen is that the engineers would look at the trend lines. Oh, well, transfer ports are moving in this direction. We'll put a dotted line that shows what will be next year. And then they would the prototype would be put on one of those little wheeled carts, and a technician wearing a company hat would wheel it to the dyno room, and those two guys would look at the thing carefully, and they would go, "Pepto-Bismol and Motrin, please." And they would get busy because they knew that the final horsepower had to come from cut and try. Nobody wanted to know what it was that these fellows were doing in the basement, but they wanted the results. And that's the way it worked. And I was therefore so delighted when I listened to conversation from a member of the original SR-71 design group who said, when we flew the prototype, we saw that one of the spars in the wing was loaded almost to yield point. And we thought, oh, we'll bend the front of the wing down like this. So they made one like that, and it was a big improvement. The airplane flew better. The stress was more equally distributed among the several spars, which a delta wing always has. And it was cut and try. It was not gigantic computers with 3,000 processors and artificial intelligence. It was real intelligence, actual human intelligence. You know, this cylinder reminds me of something I saw 3 years ago. Bud Axlin worked this way. Bud Axlin would get up in the morning, go to his shop, and start testing exhaust pipes. That one's bad. That one's bad. That one's bad. This one has some promise. That one's bad. Persistence.
Well, when Kel Carruthers kind of came out of retirement and was working on jet ski, watercraft race motors, big 3-cylinder 2-strokes, he just made pipes and he'd cut them, make them shorter, do that, do this, do that, and they were like, "Dang, this guy's making power." It was pretty cool. It was a pretty neat time to know Kel and hear about that stuff. So
because when Kel and Don Vesco had that original partnership in 1971, Kel told me years later, of course, you wouldn't have dared to speak to Kel in his years of mastery, because of course he was surrounded by phalanx of people like Pete Schick, who would look at you as if you were a worm. And may he rest in peace. Kel said Vesco had this dreadful little dynamometer off in a corner, and I went and poked around and kind of cleaned it up and got things working. And he said, I built a single cylinder test engine out of discarded crankcase. Warranty parts are a huge thing in racing development, where you're starting with production parts. And he said, I got the engine up and running, and I got it so that I could measure the torque, and I sort of knew my way around, and I started finding things out. Those were his words. I started finding things out. And roughly what he found out was the new TZ250 comes, and its compression is really dismal. It's made to run on wartime red gas, the stuff they put in Jeeps. So, and the exhaust port was, what's it doing way down there? So he would adjust the exhaust port dimensions to what he thought would work. He raised the compression ratio, and he found that raising the compression ratio brought the RPM of peak power down, because if you're taking more energy out on the piston crown by raising the compression, there's less energy going out the exhaust port. So the temperature is lower, and the pipe resonates at a lower frequency. So he took 20 millimeters out of the header pipe, or 20 millimeters out of the header pipe and 5 or 7 millimeters out of the center section. He tried stuff, and he got power. And he found his way around. He wasn't a 2-stroke guy to begin with. In 69, he got some of his world championship points on a Yamaha TD2 and some on a Benelli 4-stroke. So he found his own way. Now, Kel's a clever man, probably much better than average at finding his own way with the dyno and all those many variables, but he got hold of it. And the Japanese regarded Kelson as an oracle of excellent information. And they weren't too sure how he went about getting it, especially since he didn't attend Tokyo University. But as Mr. Yoshida, who was our technician at Kawasaki, once said, necessary many testing.
Yeah.
So
that'll be the next podcast. We'll talk about pipe design or something.
We can talk about some of that stuff. And you also said that you wanted at some point to talk about favorite tools.
Yes.
And we all have favorites, and each one of them has a story. So, as in consideration of tomorrow's breakfast, there's something to look forward to.
That's right. Favorite tools. We'll talk about maybe two-stroke exhaust pipe design and all the things working on that. And we'd already discussed doing an entire podcast on the NSR 500 evolution, basically during the McDoing years and the changes that they made from Big Bang to Screamer and all that. So we'll hit that as well. We've had some great suggestions in comments. We thank you for listening. This episode, as ever, is brought to you by Octane Lending, our parent company. There's a Prequal Flex link in the description below. You can click on that and see what you might qualify for to finance the bike of your dreams. Go check it out. It helps keep us going on this podcast. We appreciate you listening, and we will catch you next Wednesday.
You bet.